Inverse of tangent is going to have some tricks to it. It's going to take a little more work than the inverse of sine and cosine. It's mostly because inverse of sine is just the y-coordinate. Inverse of cosine is working with the x-coordinate. With tangent, it's a ratio of those two. So what we're using here is that fact that the tangent is equal to sine over cosine. So in terms of coordinates, sine was representing the y-coordinate, cosine was representing the x-coordinate. So when we work with tangent on the unit circle, it's coming through as the y-coordinate divided by the x-coordinate. So when we're looking at our unit circle, isn't just grabbing one of the values, it's dividing the two values with each other. So that's going to be part of our work with this one. So how a tangent worked originally was that we were given some angle measurement, and what we wanted to find was that y over x, or opposite over adjacent. So how it works is we input an angle measurement, and then the output was either this y over x on the unit circle, or we could think of it as that ratio of opposite over adjacent. So when we move to inverse tangent, we're going to switch these around. So this is inverse tangent or arctangent. And the input is going to be that y over x on the unit circle. Or that ratio of opposite over adjacent. And the output is what we're solving for, which is the angle measurement. All right, so similar routine as inverse cosine and sine, just have this little twist that we're looking at a ratio of 2. Now, with our graph, similar to the other cases, we can see we fail the horizontal line test, but what we can do is just look at a single period of the graph, and we would be okay. So if I limit that domain to only look at those values, and I'm restricted to being between those two asymptotes there, then we're fine. This will work great. So this is at negative pi over 2, and this is positive pi over 2. And within here, I would pass that horizontal line test, no problem. One piece of this, so we're going to restrict our angle measurements to negative pi over 2 and pi over 2, but something to notice is that we can't actually have pi over 2 itself or negative pi over 2. Since that's an asymptote, our graph never crosses those values. So when I kind of follow that notation that I was writing for the other ones, so we calculate inverse tangent only for the angles, and we would be going from negative pi over 2 to positive pi over 2, and which looks a lot like sine, but with sine we had less than or equal to, more than or equal to. Here we don't have the equality part of it. These are going to be strictly between, but we're not including negative pi over 2 or pi over 2 because of those asymptotes there. The fact that we can't plug in those angles to our original tangent function means we can't take the inverse at those values either. So when we look at our unit circle, when I draw this, it's going to look pretty much the same as what we were dealing with for sine. So we're going to be in this range, negative pi over 2 to pi over 2. Just something to keep in mind is that we don't include those endpoints there, whereas with sine, we did. Okay, so if we think in terms of some kind of key ratios, I'm just going to focus on our first quadrant here, because really it'll show up the same as in the other quadrants as well. It's just negative versus positive. So at pi over 6, my coordinate is root 3 over 2 over 1/2. And at pi over 3, I just switch those. And at pi over 4, I have root 2 over 2, root 2 over 2. So what I want to do here is just get an idea of what kind of values can show up for tangent. In fact, I'm going to throw in one more possibility right here at the angle measurement of 0. So we're at the coordinate 1, 0. So what I'm going to do is just quickly kind of do a calculation of what tangent would look like there, or rather, what does it look like to take this ratio of y divided by x. So this first one, root 3 over 2 over 1/2. If I simplify that down, tangent would be root 3. For here, tangent would take root 2 over 2 over root 2 over 2, which is equal to 1. Here, tangent would look like 1/2 over root 3 over 2, which is 1 over root 3, or if I rationalized it, same thing as root 3 over 3. And then here, for y over x, is take the y value over the x value, which is 0 over 1, which is just 0. So what I wanted to highlight here are these kind of possible values, and I'm going to include that one there too, of tangent. And this idea of like, if you see root 3 coming up in the value of tangent, then you're going to be on this increment of pi over 6. And if you see 1 coming through, then you're probably on this increment of pi over 4. And if 0 comes through, you're going to be at that angle measurement of 0. So I do this just to show you, because we had these kind of hints of like with sine and cosine looking at pi over 4 when those values showed up, and pi over 6 when those values showed up. Same idea, we just haven't really kind of focused on these as much, but now since these are going to be the input for our function, we want to be able to recognize these and have an idea of where that is sending us in terms of an angle measurement. And one second, I just have some typos down here. We'll get to this one, but we're going to take out that 2, and also we're going to focus on tangent here. So just some mistakes there. This one's all good. Okay. So here what we're doing is we're looking to find the angle where if we look at y divided by x, that ratio is equal to 1. So on the unit circle, and I know I drew this right up above there, but I'm going to explain through it again and kind of highlight my thinking of solving this. So I know we're between those two values. And then with tangent, I just keep in mind that those endpoints aren't in there. We can't really solve for them since they're undefined there, so it's not too much of an issue of having to draw it. So I just draw this kind of the same as I did for inverse of sine. Now, having a value of 1 in there, to have a ratio of 1, that's either occurring up here or down here. What's going to be key is that since it's positive, that means either both y and x need to be positive or both y and x need to be negative. And that negative scenario is happening here in the third quadrant, which is not part of our inverse tangent. So that's not a possibility. So I'm going to have to be up here. And if that input was a negative 1, then that would put us down there, because that's where we would have a positive x, negative y. So when we divide, that would make a negative. But since it's positive, we're up here. And that angle measurement that we're looking for is positive pi over 4. So inverse tangent of positive 1 is equal to pi over 4. And we could check that answer in the calculator. Inverse tangent of 1 and pi over 4, same solution. So, all right, with this one where I needed to make some corrections and get that 2 out of there. So that root 3 over 3 is going to relate to an increment of pi over 6. And with inverse tangent, we're over here. Oh, sorry, I'm just going to write that notation I've been doing. So we're looking to find an angle measurement where y over x is equal to negative root 3 over 3. Now, since this is coming out negative, that's going to put me down here where I have positive x, negative y. So I'm going to be down here somewhere. And because of that root 3 in there, my instinct is telling me that it's going to be an increment of pi over 6. And I know I drew this up above there, but let's just say you didn't have your unit circle handy, say we didn't have that graphic up above, then what I would do is kind of set it up so my x-coordinate is root 3 over 2 and 1/2. And then what we could do is like what I did up above there and look at y divided by x. So this would be a case of 1/2 divided by root 3 over 2, which is that 1 over root 3, which is the same thing as root 3 over 3. And sorry, that y should be negative, 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 negative. So that right there is our solution. I could have gone through it for this other point too, and I would have ended up with a tangent of square root of 3, and that would tell me that that didn't work. But sometimes I work through both of them to make sure I'm at the correct spot, since it's not as easy to see. So we're right there, which in terms of an angle measurement goes negative pi over 6. So this inverse tangent of negative root 3 over 3 is equal to angle measurement of negative pi over 6. Similarly, if we wanted to look at this in the original tangent function, so tangent with the input of an angle measurement, that would be the idea of looking at tangent at negative pi over 6. Then we would have looked at that sine over cosine, which would have been the same calculation, and we would have gotten that negative square root of 3 over 3. But in terms of this, that's our solution. All right, so a little trick with tangent with looking at the ratio of the coordinates, but those are our inverse trig functions we'll be working with.